regression and correlation analysis. Learning outcome number 4. Our objectives are to analyze the relationships between two variables, let's say x and y, or any other variables that we may have. We want to analyze, do we have a relationship, or if we have, which direction of the relationship, is it positive or negative? And we may want to find the regression equation which we can use to predict. So those are the objectives. So for this we are using linear regression, which consists of two variables. The independent variable, which the one which is affecting the other, the dependent variable, the one which is determined by the other. So independent is normally represented by x, dependent by y. Also, we may want to know whether we have a linear or a non-linear relationship between the variables. So we will consider our example here. Let's take two variables to be number of units and cost of production per unit. So we may use first the scatter plot, whereby we draw the x on the x-axis and y on the y-axis. So in this case our y is cost per unit. So we start with the x-axis. The smallest number is 10, the biggest number is 120. So we make our scale so that it accommodates the numbers there from the lowest to the highest. Then the cost per unit, the smallest again is 2, the largest is 10 point something something. So we make that scale. So when x is 10, y is 10. So when x is 10, y is 10, this is the point. When x is 20, y is 8.8. This is the point. So after drawing, we can see, do we have a pattern? If we have a pattern, it means we have a relationship. Like in this case, one variable was increasing, the other one was decreasing. So we have a negative relationship. So that is our scatter plot. So we may try to fit lines to see which line can fit there. We are trying to find the regression equation. So we can come up with many. But now, the regression equation, or we call it least squares, it tries to minimize the errors. We want to find the line of best fit, which minimize these errors. These were our variables, let's say our points on the scatter. So we want to minimize these errors. So how do we find it? We should calculate the line y is equal to a plus bx. So basically what we need here is to know it's a and b. X and y are part of the formula. So if we want to represent the error, we add it here. But now we have to do the regression equation. Y is equal to a plus bx. So b is sxy over sxx, whereby sxy is given by summation of xy minus 1 over n summation of x times summation of y. When we say summation of x, we add all these values. With the answer that we get is the sum of x. Summation of y, we add these values. The answer that we get is the sum of y. N are the number of pairs. So here we have 8 pairs. xy we get it by saying x times y. We create a column, then we add. So that is the so now the thing is, we now have our xy, we now have our x, summation of x. So we can now calculate sxy from this, it was saying summation of x squared, which we found here, minus 1 over n, which is 1 over 8, times 470, which is sum of x squared. We get the answer here, we get the answer here, we divide. So when we divide SXY and SSX, we get B, which is minus 0.07. Then we find A by using the formula A is equals to Y mean, meaning summation of Y over N, minus B X bar, which means it's summation of X over N. So if you subtract, we get A. So now our equation was Y is equals to A plus BX. So A, we know it, B, we know it. So this will be our equation. But we can use it to predict. Let's say we know that X is 30. We want to find Y. So we replace 30 where there is an X. So we find now that when X is X, the Y is 7.94. So we can use it for prediction purposes. So then now there are certain relationships now which can come after we calculate, or either we do the scatter plot. These are the possible scatter plots that we can get. If we get a straight line going up like this, it means there is a perfect positive relationship. Positive means going up. If it's close to each other, it's strong or high positive. Not close, low positive. Going down, negative, negative. If it's straight line, perfect negative. Now another example, we are given a data at Nalet in a police station in Havron, whereby we gathered the number of police officers and the number of crimes which they have reported. So it's when they were 10 police officers, they reported 31, 18, 26, like that. We want to find the coefficient of correlation, the small r. So first, before we do anything, we make a table for x, y, xy, xx or x squared, y squared or yy. So when you say xy, we mean 10 times 31, here 310, 18 times 26, we create a column, the total that we get is this. It means you are supposed to fill in the gaps using the format that I have shown you. 10 times 10 is 100. You do the same. 18 times 18, like that, you fill in this is 10 to 5, 76. Then for y squared 299. Then now we have a formula for correlation coefficient. So it's summation of xy minus summation of x times summation of y divided by square root of summation n summation of x squared minus summation of x squared n summation of y squared minus summation of y squared. So substituting our values which we found from above, n is 8, summation of xy is 3693, summation of x squared is 10576. So it's a matter of now substituting, and we get the answer minus 0.92, which is strong negative relationship. So this formula, it must not scare you, because it will be provided in the formulas. Then the regression equation now. B, this is xy, so now I have just put it direct like this. N summation of x, xy, summation of x, summation of y over this. It's a formula, so we can write it on like for the one on top or this one. So this is squared. Don't confuse it to 2. This is squared. It's only that I didn't type very well. This is squared. So after substituting these values we get b. Then we use the b